Most of the people in here, I think I already know. Thank y'all for coming out. I really appreciate it. This is a talk that I've been dying to give for several years now. It's been a personal journey for me, learning about diet and nutrition. Something I'm very interested in. I read about it all the time. It's kind of a long story how I got into it, but I just kind of ran with it, and I found it very interesting because I learned a lot of things that contradicted what I was taught in medical school, and that alarmed me. It upset me, so I wanted to correct it, and it's just steamrolled, and I really learned a lot, and I think it's a low-hanging fruit for me to address with patients. It's something that can really help people. You know, every doctor can talk to you about the medications, but I think doctors don't spend enough time talking about this kind of stuff. So there's a lot of stuff I want to cover, so I'm just going to jump into it. So I have a few disclaimers first. There's no solid, irrefutable evidence that any diet or vitamin or food is definitely beneficial to Parkinson's. There's some very good studies, very interesting studies that we'll talk about. I think some of them are going to prove to be correct with more studies, but we really don't know for sure yet. We need multiple placebo-controlled prospective studies. That may not happen, though, because of the nature of food studies, which I'm going to get into. And then finally, there's a lot of things that are my opinion here. Question everything, don't believe me, do your own research. So I've learned that you have to question everything, basically. One problem with food and diet is that it's very expensive and difficult to study. In order to study something properly, you have to regulate what people eat strictly for a long period of time. And that's just very impractical, it's very expensive, and who's going to pay for it? Because, you know, pharmaceutical companies, we need them, they're an integral part of treating Parkinson's. Of course, without the meds, people would be in a bind and not doing well. But drug companies can't make money off of selling food, so it's not really, so the money's not there to do the research. It's hard to isolate the effect of one type of food when people have to eat multiple things. You can't eat one single type of food, you know, for 2 months. It can't happen. And then to make things even more complicated, everybody has different genes, different metabolism, and so foods have different effects in different people. So it just increases the complexity, and then people have different allergies and food sensitivities. Even different medical conditions affect how our body handles food. Even things in the environment affect our body and affect how we handle food. Bacteria and viruses we're exposed to, chemicals we're exposed to, everything affects it. So everybody, so I really don't think there's a one-size-fits-all diet. I don't mean to say that at all. We all know people who are really thin and they eat, you know, fast food and sugar all the time, and you wonder how they do it. Well, they have a different metabolism. But everybody has a different diet that works for them. Different things are available in different areas. You know, we live in Louisiana, and you can go get boudin or crawfish, boiled crawfish, but you can't get that almost anywhere else in the country. And so culture plays a big part of it, availability, and like I said, food sensitivities. People ask me a lot about vitamins. Which vitamins should I be taking? Well, in general, the good news is that vitamins are very healthy and safe, but they're not regulated by the FDA, so they're not really studied as rigorously, not even nearly as rigorously as prescription drugs, which, as you heard earlier, cost $500 million to $1 billion to develop each individual drug. So I think companies that sell vitamins, you know, they can help people, but they can really say anything they want. So you have to take that with a grain of salt. One vitamin that showed promise in Parkinson's disease about 10, 15 years ago was Coenzyme Q10. And because a small study showed that benefit in Parkinson's, everybody got very excited. We recommended CoQ10 in high doses to our patients for years, but then when they did a larger study to try to confirm it or quantify the exact nature of the benefit, the study showed that it was not helpful after all. So that was disappointing, but I think we learned a lesson. I think in general, there's some vitamins that are important for the health of the brain, and it's mainly the B vitamins, especially B12. Fish oil is very good for the brain. It also has anti-inflammatory properties. Vitamins D, E, and C, I think, are very good supplements, and magnesium is overlooked. Magnesium, incidentally, is good for muscle relaxation. A lot of people think potassium is what they needed to have muscle cramps, but it's more magnesium, actually. And magnesium and potassium work together, but magnesium is something that a lot of people are actually deficient in. It does not show up on a blood test. So then there's some anti-inflammatory vitamins and supplements that would theoretically be helpful for Parkinson's, but really almost every disease is due to inflammation, so you could say that they would help almost anything theoretically. These three I have listed here, especially glutathione. There's some small studies showing that even IV infusions of glutathione can be helpful, and I know some people who have actually tried that. One of the big things I want to talk about today, spend a lot of time on, is the microbiome. So that's the word that refers to all the bacteria that live inside and outside of us. I think, it's kind of a hard concept because you can't see it. And so it really, and it's hard to study, but we now know that these bacteria that live in our body, they outnumber our own cells 10 to 1 in each individual person. And that's because they're so small, and there's so many of them, 100 trillion bacteria in and around our bodies at all times. To me, that's an amazing number. That's a lot of zeros. If you were able to put all these bacteria in a container, it would be about half a gallon worth, okay? So, and that's, now it makes more sense if you think about that spread all throughout, tens of feet of your intestines and all your body surface area. There's a lot of surface area to cover in and out of our body, and they do cover it. So far, we've identified 1,000 species in our gut. Of course, some are good and some are bad, and that's what we need to figure out. What do these bacteria do? Well, in the gut alone, they help us digest the food. They're the very first thing that food encounters is the bacteria. They are literally the first line of defense. They help us absorb nutrients, break down the food. They help us absorb vitamins, and they produce vitamins. They kill bad bacteria. They neutralize toxins. They help to regulate our hormones and our immune system. And therein lies the key, in my opinion, to how these bacteria help us or hurt us, depending on how we're able to influence them. So inside the gut, there's the bacteria is the first thing that food would see, and then past the bacteria, there's the gut itself, the one cell layer of the intestines, and then just on the inside of that is the immune system. And that's actually where 70 to 80% of our immune system lies, is in the gut, just one cell away from the food and the bacteria. These gut bacteria actually make most of our body's serotonin, which is the hormone that is the happy hormone. Most antidepressants increase serotonin, but most of the serotonin we make is not from our brain, it's from the gut. Very interesting fact. So we're just learning the extent of how these bacteria influence our body. And it's not just humans, by the way. Every single animal and plant on the planet has a microbiome that has been around since evolution started, and all these organisms have always had these bacteria around. It's a symbiotic relationship. They help us, we help them. The first organism was a sea fan 500 million years ago, it had bacteria on it. So this is nothing new. So what influences the bacteria that are in the gut? Well, first of all, childbirth. From the second we're born, you're either born from C-section or natural childbirth. And that path through the vaginal canal actually seeds our bacteria in our gut for the first time. That's where it starts. That's what nature intended. If you get a C-section, that's necessary a lot of times, but it does bypass the initial seeding of the gut. Breastfed babies versus formula-fed babies. Obviously, breastfed babies have an advantage there. Of course, diet, and that's what I'm going to talk a little bit about. What we eat influences it. Our behavior, in terms of exercise, smoking, exposure to chemicals, antibiotics, which are designed to kill bacteria sort of indiscriminately, by the way. So these antibiotics kill bad bacteria, we hope, when we have an infection, but they also kill a lot of good bacteria. Environment. So there's bacteria in the air and the dirt, and some of that's good. A lot of that's good. Just getting back to childbirth, of course, I kind of mentioned C-section. You don't get that initial seed of the bacteria, and we now know that has effects for someone's whole life. 5-fold risk of allergies, triple the risk of ADHD, twice the risk of autism, even increases your chances of being obese as an adult. And people, I mean, it's an amazing connection, but it's been confirmed by studies. More likely to get autoimmune diseases. And C-section has increased by 50% since 1996. So I think it's necessary and it saves a lot of lives. It's wonderful. But when it's done for convenience, it might not be the best thing in the world. So another interesting thing is that because these bacteria outnumber us so much, and they have their own gene too. They have their own genes inside these one-cell organisms, and their genes outnumber our genes 360 to 1. So if someone thinks that these genes don't influence our genes, they're really kidding themselves. They have a huge influence, and we're just beginning to understand it. A little historical perspective, Hippocrates said 2,000 years ago, all disease begins in the gut. And what makes that interesting is that bacteria weren't even discovered until the 17th century. So he said that 2,000 years before we even knew what bacteria were. And then a Nobel laureate was the first to say that good bacteria must outnumber bad bacteria. And that was about 150 years ago. The NIH launched a human microbiome project in 2008 to really address this matter. And now we know that the microbiome is linked to 90% of all human disease, including Parkinson's disease, which we'll talk about. So we heard earlier about alpha-synuclein. That's the protein that accumulates in the brains of Parkinson's patients. That's the protein that's in Lewy bodies. So we knew Parkinson's patients had Lewy bodies in their brain. We've been knowing that for decades. We didn't know what was in the Lewy body until the 90s. We discovered it was this protein, alpha-synuclein. Alpha-synuclein is made by our own bodies. We don't know exactly what it does, actually, but when it's misfolded and starts to accumulate, it's a big thing that causes Parkinson's. It may not be the only thing or the biggest thing, but it's definitely an integral part. So one study looked at colon biopsies from Parkinson's patients, but they looked at the biopsies years before they had Parkinson's. And they discovered that alpha-synuclein, the misfolded abnormal alpha-synuclein, was found in the nerve cells in the wall of the colon way before they experienced any Parkinson's symptoms. 10 to 20 years before, which is amazing. A lot of patients with Parkinson's we know have constipation, 80%. It's probably a big reason why. So a lot of researchers speculate that the colon biopsy may be a biomarker one day. It may be able to identify Parkinson's before people have symptoms. which is what we really need for research purposes, as we learned earlier from Michael J. Fox Foundation. So we do know in the brain that the alpha-synuclein begins to accumulate in the central nervous system in the lower brain stem. And one of the main parts of the brain it starts in is a dorsal motor nucleus. Well, guess what that controls? It controls the gut. The microbiome has been shown to influence the amount of inflammation in the brain. Parkinson's has a strong inflammatory component. So these are all compelling reasons why this is very important for Parkinson's. This doctor here, who I cannot pronounce his name, but he did a study where he looked at the types of bacteria in Parkinson's patients versus healthy controls. And the healthy controls had a predominance of good bacteria, and the Parkinson's patients had a predominance of bad bacteria. So he concluded that these pro-inflammatory bacteria could trigger inflammation, which could trigger the misfolding of alpha-synuclein, which leads to Parkinson's. Here's another study by Dr. Sampson, 2016. This was a landmark study that came out last December. This is the main reason that inspired me to give this talk here today. But this is the first study that showed these gut microbes play probably a direct causal role, at least in a mouse model of Parkinson's. So what we've done is, in order to have a mouse model of Parkinson's, they took the alpha-synuclein gene and they manipulated it so that these mice overexpressed alpha-synuclein so that it would be more likely to misfold. So basically these mice would almost all get Parkinson's. So they could study things to try to cure Parkinson's. Well, he took some of these alpha-synuclein mice and he raised them germ-free, and he found that they didn't really get Parkinson's quite as much. They had less alpha-synuclein in their brains compared to the mice that were not, germ-free. That's one piece of evidence. We know that bad gut bacteria make a certain type of chemical called short-chain fatty acids. It's a type of fat. It's inflammatory. So he took the short-chain amino acids that cause inflammation, he injected them into some germ-free mice, and they had more Parkinson's. These mice had more Parkinson's, more alpha-synuclein in the brain. That's another piece of evidence. Third piece of evidence. They took some of these germ-free mice that overexpressed alpha-synuclein, and they injected them with real bacteria from real Parkinson's patients from their gut, and the mice developed increased Parkinson's. So this means the gut bacteria seem to be directly influencing the symptoms and the pathology in the brain in Parkinson's disease, at least in a mouse model. So that was a wake-up call for a lot of doctors that this is really something that we need to start looking into a lot more. Here's another study. I'm going to touch on this briefly, but there's a nerve that connects the lower brainstem to the gut. It's called the vagus nerve, and there's some medical conditions where patients have to have the vagus nerve cut to treat their medical condition. That's called a vagotomy, and they found that people who had vagotomy were less likely to get Parkinson's, which sort of implies that maybe something travels up that nerve from the gut to the brain, and it may help start it in the brain. Interesting. So what can we do to fix our microbiome? So I'm telling you it's important, you believe me. Well, doc, what do I do? Well, I don't know. We're just scratching the surface of this. There's thousands of species of bacteria that are good. We don't know which ones are good or how to deliver them or what ratio. We don't really know any of that stuff yet. My 2 cents, and that's maybe all it's worth, is to take probiotics. So those are food and supplements that actually have the good bacteria in it. To ingest foods that are prebiotics, which feed the good bacteria. To avoid inflammatory foods that kill the good bacteria. Avoid unnecessary antibiotics. I'm I'm not saying if your doctor gives you antibiotics, I'm not saying don't take it. You know, they save your life, okay? If a doctor gives you antibiotics, please take it. But there's antibiotics in most of the food that we eat. Unless you buy organic meats, they give antibiotics to animals to make them fatter, which I think is another interesting conversation to be had, is that they give the antibiotics to the cows to make them fatter. Well, they're probably doing that to humans too. But we shouldn't maybe be ingesting the antibiotics in our food supply. So probiotic foods include a lot of fermented dairy products. So that means yogurt, cottage cheese, kefir is another dairy product. There's kombucha. There's all sorts of fermented vegetables like sauerkraut and kimchi, miso soup. Really, every culture in the world that's been a mainstay of diet, because they didn't always have refrigerators, and fermenting food was a way to preserve the food and eat it later. Probiotic supplements, I think, can play a role. These are basically pills that have the good bacteria in it, but I think since we don't know which ones are good, I would say try to get a supplement that maybe has a lot of different bacteria in it, the most number of different species, and maybe rotate the supplements that you take to get exposure to a lot of different ones. Prebiotic fibers are the food for the good bacteria. So some of the food we eat is in turn digested by the good bacteria that encourages the health and propagation of these good bacteria. It's a lot of things you probably don't think about a lot, but raw vegetables, and they're all listed here. But when you cook these vegetables, it breaks down the fiber. The fiber is what feeds the good bacteria. So when you cook food, it really breaks down a lot of that good stuff. But what's interesting with potatoes, if you cook the potato and then you let it cool, the fiber comes back into it, and it's a prebiotic fiber again. So potato salad, prebiotic fiber, yes. Baked potatoes, no. So getting back to the fiber thing, so green bananas and green plantains, they have the prebiotic fiber because they're not ripened. But as they ripen, the fiber gets lost. They become sweeter, right? So they lose that fiber. You can buy potato starch, which I recommend if you do that to add very slowly, because it's also a treatment for constipation. And in fact, I give a handout to my patients. I've been doing that for 6 months or a year now as a treatment for constipation, and fingers crossed, hopefully will help with the gut bacteria too. And there's a study in the journal Neurology that proved potato starch is a helpful treatment for constipation in Parkinson's patients. So that's been confirmed. All right, I want to talk about ketogenic diet. So when we eat food, there's a ratio of carbohydrates and protein and fat. Okay, so most Americans, most people around the world eat a diet that's high in carbohydrate, moderate protein, and low in fat if we listen to the government. Well, ketogenic diet flips that completely. It's high fat, moderate protein, very low carbohydrate. So here's an example of a typical ketogenic diet. And it may even be 65 to 80% of calories from fat, 20-30% protein, and 5% of calories or less from carbohydrates. If you're able to do that kind of a diet, which is not easy, by the way, if you're able to do that kind of a diet, your body, your liver will start making ketone bodies for energy. That's a state called ketosis. And ketone bodies are an alternative energy source for the brain and other tissues. Ketone bodies have antioxidant and anti-inflammatory properties. A lot of people out there think ketogenic diet is not healthy, but if it was not healthy, then it wouldn't be exactly what breast milk is. So breast milk is a pure ketogenic diet. It's 80% fat, 5% carbohydrates, and 15% protein. And that's what babies need to thrive and survive. So it's in nature. Another way I know it's in nature is because another way to go into ketosis is just not to eat. So if you go into a fast or starvation mode, your body will go into ketosis to make energy. If you think about it, as humans and humanoids were evolving, we didn't eat 3 square meals a day. We're hunter-gatherers. We ate a big meal and then we didn't eat for a week. Okay, so the whole week they're in ketosis. So probably most of the time, most of our existence as a species has been in ketosis. Therefore, we're very keto adapted as an organism. It makes sense because when you're starving, you need to eat. And if you need to eat, your vision needs to be sharp and your thinking needs to be clear to get the next meal or you will die. So it makes sense to me that ketosis, you actually function better and sharper because you need to, at least if you're capable of it. So this keto adaptation was actually selected out, evolutionarily speaking, and you were more likely to survive if you were more keto adapted. So that's why we're so keto adapted now as a race. This is a study that just showed that there's neuroprotective and disease-modifying qualities in animal models of Alzheimer's, Parkinson's, traumatic brain injury, and stroke. Okay? This diet was used to treat epilepsy 80 years ago when we didn't have any medications for epilepsy. So this is not a new thing at all. It just lost favor because it's hard to do. Well, it's making a comeback. It's studied in some other things. It's actually a very efficient way of burning fat in the body. It turns the body into basically a fat-burning machine. Whereas if you eat a high carbohydrate percentage, that turns your body into a fat storage machine. But the diet is very difficult to maintain. And there are some medical conditions where this diet is not safe. Severe liver disease, porphyria, some rare genetic things that are like 1 in a million or 1 in 5 million people. So almost everybody, it's safe. This is not about Parkinson's, but this is a study that just blew me away. So when patients are having a seizure and we can't stop the seizure, we call that status epilepticus. So if the seizure lasts more than 20 minutes, we say that a patient is in status epilepticus. Very dangerous condition, high rate of death from this. So these were 10 patients who were in status epilepticus or continuous seizures for 21 straight days. 21 straight days. And these patients were on 7 different anticonvulsant medications to try to stop the seizures, and they were still having seizures after 3 weeks. So these patients were basically written off, okay? We can't stop the seizure. Basically, they were just going to die. Well, they said, well, let's put them in a study and put them on a ketogenic diet. I mean, they can't eat anyway, so we're giving them all the food through their stomach. Let's just put a ketogenic tube feed down the tube and see if it stops the seizures. After 3 days, 9 out of the 10 patients achieved ketosis, and all 9 stopped seizing. And most of them walked out of the hospital. So to me, that's just super powerful. In rat models of Parkinson's, ketogenic diet has been shown to protect neurons. I won't get into that probably scientific study. Okay, this is the one ketogenic study on Parkinson's in human beings. One study done in 2005 on 5 single patients. And one of these doctors, Dr. Hempsfield, actually works here at Pennington, and I talked to him about the study. So they took 5 patients, and they told them to eat a ketogenic diet, 90% fat, 90% of calories from fat. So they called it a hyper-ketogenic diet, but they did that for 30 days. And they were dedicated to this diet. All the food was given to them, they basically did it. These were people of all ages. Some of them had Parkinson's for 6 months, some as far as 12 years. There were almost all on Parkinson's medications. And the way that they check to see if this would help the patients would be to look at their Parkinson's motor scores, which is UPDRS. So that puts a number to how bad your Parkinson's is. So they did that at the beginning of the study and after the 30 days were over. And what they found was their motor scores went down 20 to 80%. That's more powerful than all of our medicines. But this was never studied again, which is amazing to me. How is that possible? But I think there are studies going on now, and it is being looked at, and I can't wait to see the results. I actually wanted to study it myself, but it's you can't get funding to do something like this, and it's very complicated. When I started looking into it, it's very difficult to do.